We're still going to work on graphing our linear equations, and we're going to also use a new method today, and that involves us using the slope-intercept form of a line. The slope-intercept form of the line is y is equal to mx plus b, and we're going to find that we'll use this as another form of a quick graph. No table of values, no finding x or y. If it's in the right form, we'll be able to identify two key pieces of information and graph. So first off, the line has to be in slope-intercept form. If it's not, we'll rewrite it, and we've done that before. We're then going to identify our y-intercept, which is b, and that's that point that crosses the y-axis, and we'll graph that first. From that point, we're going to take the slope to plot additional points, at least one. I'd like to do at least two, though, and then sketch the graph. So let's take a look at some problems. I'll start off with the type that already have the equation in slope-intercept form. This makes our lives a little easier. Y is equal to mx plus b. M represents our slope, which is rise over run. It's going to tell us whether we're going up or down, and then across, left or right. And then we'll have our y-intercept, which is b, which is our point on the y-axis. And you always start graphing with the y-intercept. So number one, let's identify. My slope is -3, and my y-intercept is 5. Now slope is a ratio, so it's going to be -3 over 1, which tells me it's going to go down and to the right. Start your graph with your y-intercept. We know that's that point that falls on the y-axis. That's easy enough. So b is 5. 1, 2, 3, 4, 5. There's my first point. Now I'm going to secondly use my slope. Graph another point. So now here we have to utilize that rise over run. I mentioned that it's negative, and I know that because the number here was negative. And if it's a whole number, it will be over 1. Negative tells me to go down 1, 2, 3, and 1 to the right. And there's my graph. We see that the line is negative, it's going downhill, and my number was negative, so that's another indicator it was a negative slope. When the equation's in slope-intercept form, this becomes a very quick method. No additional steps. Let's see a few more just to practice. In this one, I identify my slope. I don't generally like to write it like this, but it's 2 over 3x plus 1. So my slope is a ratio of 2 over 3, rise over run, and my y-intercept is 1. It's positive. It's telling me to go up 2 and over 3, rise over run. So we'll start by graphing my y-intercept, a point on the y-axis, and that would be, oh, I think I put that in the wrong place, excuse me. It should go right there. There's my 1. Okay. Now I'm going to go up 2, 1, 2, and over 1, 2, 3. Now slope is constant. I can do an additional point. 1, 2, 1, 2, 3. And again, if I want to, I could extend it down 1, 2, 1, 2, 3. Sometimes if we're doing rough sketching, we're not using a ruler. We might want to be sure that we're a little more accurate with this. And there's our graph. Rise over run. And again, slope is a constant, so we can do more than one point. Positive slope, and 2/3 was positive. So again, the graph matches the number value of slope. This next equation is not in slope-intercept form, so I have to rewrite it first. What do? It's in standard form. I have to isolate y, so let's add 2x to both sides. I get 3y is equal to 2x plus 6, and then we'll divide all terms by 3. What does that leave me with? Y is equal to 2/3 x plus 2. Identify your slope, that's 2 to 3 ratio, and my y-intercept is 2. Slope is positive, it's going to go up 2 and over 3. Start at your y-intercept, that's 2. Count up 2 and over 1, 2, 3. It's always up and to the right or down and to the right. If I wanted to plot an additional point, I could go up 2 and over 1, 2, 3 again, just to get a sense of the graph. Connect my points. It's just that easy. The more you do, the easier it becomes. The key to this is making sure that your equation is in slope-intercept form. Here's another example, excuse me, where we need to rewrite. I will start by subtracting 4x on both sides. That leaves me with a negative 2y equals negative 4x plus 4. Final step here is to divide all terms by negative 2, watching my signs. Y is equal to, negative divided by negative is positive 2, and this gives me a negative 2. Slope is 2, y-intercept negative 2. Whole number over 1, telling me I'm rising, positive is rising, up 2 over 1. Where do I start graphing from? The y-intercept, negative 2. Tells me to rise, go up 2 over 1. I want to do that again, up 2 over 1. If I wanted to extend it down, and then I connect. All right, so the key to this is if it's in slope-intercept form, just identify the 2 and graph. If it needs to be rewritten, you have one additional step to do. And again, these are not hard, it's just thinking about what we need to do. Let's just practice. Sometimes we need to see an additional problem, and I can do as many as you like in person. Feel free to ask for extra help on this if you need it. Let's divide by 2. I'm spending a little more time on the ones we need to rewrite because those are the ones that require a little bit more details. Follow the steps here. I subtracted 5x on both sides. I then divided by 2. I identified my slope as being a negative 5 halves. I already know my graph is going to go downhill, and my y-intercept is 4. Graphing, always graph with your y-intercept form because that's a given point. And there's my y-intercept. My slope says there's a negative, so I'm going down and to the right, counting down 5, 1, 2, 3, 4, 5, and over 1, 2. Again, if we wanted to, we could extend that a little bit more. You only need 2 points, but sometimes if you're trying to be extremely accurate, you might want to use a ruler, and you might want to plot additional points. So again, what did we hope to accomplish today? Another form of quick graph. This one utilizes the slope, intercept, and the slope and the y-intercept. If you need to see additional problems, we'll start with this one in our class when we meet up today.